This video will demonstrate how to solve commercial and financial math problems using the BA2 plus Texas Instrument calculator. First, we will explore how to insert long equations. Using the example, 96 minus 6 minus 4 squared times the cube root of 7 minus 2. Press second, format, down, down, down. Then change to AOS. Then press second, quit. To insert the equation, enter 96 minus bracket 6 minus 4 to the power of 2 bracket times 7 to the power of bracket 1 over 3 bracket minus 2, which gives us an answer of 113.13. Next, we'll explore how to calculate dates using the example, how many days between January 4th, 2015 and June 7th, 2015? Press second and then 1 to enter January 4th, 2015. Press 1.0415. Press down to enter the next date, June 7th, 2015. First, enter 6 for the month of June, and 07 for the day, and 15 for the year. Press down and then compute to calculate the number of days between these two dates. The answer is 154 days. Now we will explore how to calculate the break-even point using variable and fixed costs and revenue. Variable cost is $13.90 per delivery, and fixed cost is $6,640 per month. And the revenue per delivery is $60 flat. What is the break-even amount of deliveries? Press second and then 6 to reach break even. Enter the fixed cost of $6,640, then press enter. Then enter the variable cost of 13.9. Press enter. Then enter the price of $60 and press down. Enter 0 for the profit and press enter. To calculate the number of deliveries required to break even, press compute. The answer is 144.03 deliveries. Next, we will try converting interest. Using the example, a customer's nominal rate is 12% per year. What is the largest effective rate the customer can get? Press second and then 2 to begin the converting interest function. Next, enter the nominal rate, in this case 12%. Then, change to compounding daily by entering 365. Next, press up and compute, which gives us 12.75% compounding daily. Next, we will calculate the time value of money. N for the time should always match the payment period. So if the payment is monthly, N should be the number of months in that period. The IY value is always the nominal rate you are given in the question. For the second interest rate, enter the payment and compounding based on the question. PV equals the present value, or the money you have now. PMT equals the amount that you put in or withdraw each period. Future value equals the money you will have in the future. Outflow should be negative and inflow should be positive. Here is an example of how to calculate future value. What will be the maturity value of $10,000 invested for 5 years at 9.7% compounded semi-annually? First, enter $10,000 for present value. Next, enter 10 for N. The IY value is 9.75. And then enter second IY and payment per year, and compounding per year. They are both 2. Now enter second, quit. Payment equals 0, then press compute, future value. The next example shows how to calculate equivalent payment at an earlier date. Mr. and Mrs. Espedito's property taxes, amounting to $2,450, are due on July 1st. What amount should the city accept if the taxes are paid 8 months in advance and the city can earn 3.6% compounded monthly on surplus fund? Enter $2,450 for future value. $8 months for N, and 3.6 for the interest rate. The compounding is monthly, so press second, interest rate, and then enter 12. Payment is 0. Press compute and PV to get the answer. The next example shows how to calculate the rate of return. Mr. Dunbar paid $10,000 for a $40,000 face value strip bond having 19.5 years remaining until maturity. What semi-annually compounded rate of return will Mr. Dunbar earn on investment? 7.24% compounding semi-annually. The present value is the amount paid and must be minus, so enter 10,000 minus, then PV. The future value is 40,000. The N value is the number of semi-annuals over the period, in this case, 19.5 years times 2. Payment is 0. The compounding and payment period should be 1. Next, enter second, quit. Press compute, IY, and get 3.6185. Multiply that by 2 to get 7.24%, or the compounding semi-annual rate. Next, we will calculate the number of compounding periods. Using the example, what is the term of a compound interest GIC if $4,000 invested at 5.5% compounded annually earns interest totaling $1,227.84 over 5 years? Because the present value is outflow, it must be entered as a negative, so for present value, enter negative 4,000. The future value is the present value of 4,000 plus the compounded interest of 1,227.84. The interest rate is 5.5%. The compounding is 1. Next, press compute and then N. The answer is 5 years. Next, we'll calculate annuity future value. Using the example, Heinz has been contributing $300 at the end of each month for the past 15 months to a savings plan that earns 6% compounded monthly. What amount will he have 1 year from now if he continues with the plan? Present value equals 0. Heinz contributes $300 per month, so PMT equals 300. N equals the number of total months, so the past 15 months and the next year. The interest rate is 6%, and we change compounding to 12 as it is monthly. Now press Compute Future Value to get the answer. Now we will calculate the present value of annuity. Suppose the funds used to purchase an annuity will earn 6% compounded monthly. What amount is needed to purchase an annuity paying $1,000 at the end of each month for 20 years, or $139,580.77? Enter 0 for future value. $6% for the interest rate, and the compounding is 12. The payment is $1,000. N equals 20 years times 12 months, or 240. Next, press Compute Present Value to get the answer. Now we will calculate payment for annuity. Mark wishes to accumulate a fund of $300,000 during the next 18 months. What should the monthly end investment be in order to reach the savings objective? Interest 3.6% compounded monthly, or $16,245.70. First, enter 0 for the present value. Then $300,000 for the future value. N equals 18 for the number of months in this period. The IY value is 3.6%, and the compounding value is 12. Finally, press Compute PMT to get the answer. Next, we will calculate the number of payments for annuity. 1 month from now, Maurice will make his first monthly contribution of $250 to a TFSA. Over the long run, he expects to earn 8% compounded annually. How long will it take for the contributions and accrued earnings to reach $100,000? Present value equals 0. Future value is $100,000. The payment value is negative $250. And the interest rate is 8%. The payment is 12. However, the compounding is 1. Now, press Compute N to get the answer of 198.58 months, or 16 years and 7 months. Finally, we will calculate the interest rate for annuity. A life insurance company advertises that $50,000 will purchase a 20-year annuity paying $341.13 at the end of each month. What nominal rate of return and effective rate of return does the annuity investment earn? Set the present value to negative $50,000. Future value to 0. Set the payment to $341.13. And N to $240. The compounding value is 12. Then press Compute IY, which gives you an answer of 5.4% compounding monthly. This is the nominal rate, which must be changed to the effective rate. To do this, press second 2. Enter the nominal rate of 5.4. Press down twice and enter 12 for compounding, as it is compounding monthly. Finally, press up and then compute. This gives us an answer of 5.54% per year as the effective rate.